We're going to learn how to use the percent error formula. The percent error formula provides a quantitative indication of how close an experimental value is to an actual known value. Quantitative means numbers, and percent means exactly what it says. So you're going to have at the end a number in percent form. The formula for finding the percent error is you take your actual value, subtract it from the experimental value. That subtraction, you're going to only have the absolute value. So make it positive if you calculate it to be negative. These lines right here indicate you only want the absolute value, or make the value positive. You're going to divide that subtraction by the actual value and then multiply everything by 100 to get a percent. This formula really just tells us how close we are to the actual value. The smaller the percent error, the closer the experimental value is to the actual value. In order to show this, we're going to go back to our density of a sphere lab. During that lab, I asked you to find the density of this unknown sphere. I didn't tell you what the material is made out of, or the sphere is made out of. And I had you make an attempt to infer the identity of your sphere using your density value as well as this chart. We'll come back to this one in a second. In order to complete or show you how to use this particular formula, I needed an experimental value. So this morning I came in and I collected this data on this particular sphere, same sphere that you had. I did 2 trials. I have masses for those trials. I had volumes for those trials. I did use our density formula, calculated density, and found the average from my 2 trials to be 7.5 grams per milliliter. This was completed in the lab, so that is the experimental value. I'm going to abbreviate that. I'm not going to write out experimental value because that's a lot for our list of variables. So I'm just going to write EXP for experimental and then V. My experimental value is 7.5 grams per milliliter. I'm going to tell you now the identity, or what this sphere is actually made out of, the sphere that you did your project on, and that sphere is made out of chromium. The actual value for the density of chromium is 7.19 grams per centimeter cubed. This is a value that has been accepted by the scientific community after a lot of trials. You can find a whole bunch of physical property characteristics that have been accepted values in the back of your textbook or online, and we're going to use that quite often to see how close we are during the experiments to the actual value. So again, from the chart I have 7.19 grams per centimeter cubed. These 2 units of volume are not the same, but I do need to have them the same, and we learned that 1 milliliter is equal to 1 centimeter cubed, so I can just change this to milliliters. In order to do math with units, your units do need to be the same. As you can see, my experimental value is not identical to my actual value. It might have to do because I only did 2 trials. It could be that I didn't read the graduated cylinder perfectly. There could be something off with my scale. And all of those things don't mean you did anything wrong or bad. It is just the nature of doing things in a lab. So I have my 2 values. I have percent error is equal to the absolute value of my actual value minus my experimental value divided by the actual value times 100. Underneath that, I'm going to plug in the numbers. So I have 7.19 grams per milliliter minus 7.5 grams per milliliter divided by the actual value 7.19 grams per milliliter times 100. I'm going to take my calculator and do the subtraction first. 7.19 minus 7.5. I get negative 0.31 grams per milliliter. I'm keeping my absolute value signs. Divided 7.19 grams per milliliter. As I talked about earlier, this is an absolute value. So I'm going to drop the negative sign I'm going to divide 0.31 divided by 7.19. Oops, that should be a times. I'm going to multiply it by 100. And I get 4.3% error. For now, you can still round to the tenths place. And what this number means is that since it's a small number, it means that I am pretty close to the actual value. I only have 4.3% error. Sort of like getting a 96 on a test. And that is how we calculate the percent error.